We're dealing with trapezoids, rhombuses, and kites. First one we're going to talk about is the trapezoid. Remember, in the trapezoid you have bases that are parallel. Sometimes that comes in handy. So since these are both bases and the other two sides are both legs, okay, you want to make sure you know where your bases are. They are parallel. You're calling one of them base 1 and the other base 2. Those are subscripts, not exponents. So you shouldn't be squaring or doing anything weird like that. It's just to distinguish that they are separate values. They should not be the same. Okay. Now, between those bases, you have a height, which needs to be perpendicular to the base. So when I said before that you wanted to make sure your base and your height were perpendicular, this is the same thing. Okay, now there is, we could spend time rearranging things and talking about how they work out, to relate back to the area of a rectangle, but you're not probably going to remember that anyways. So in this case, I'm just going to give you the formula. And this is one, I don't care so much if you don't write the formulas down for a rectangle or a triangle, but this one gets a little more involved. So I prefer that quiz test, and you might want to do it on your homework as well so you know what you're using. You do write the actual formula down before you plug anything in. So it's 1/2 times the height times the sum of those bases.
So is that the same as doing height times the base? Is that it?
All divided by 2. So you can do this and divide by 2 at the end. Okay. All right, so the first one we're going to look at would be where your information is already given. And this is actually an outline of Arkansas. Not perfectly, but so these are all in miles. So in this case, we'd have half of our height times the sum of our bases, so 250 plus 190. Now, how you go about applying order of operations from here is up to you. If you wanted to do half the height, and do your sum and then multiply the 2, you can do that. Or if you want to do the sum times the height and then divide by 2, you can do that as well. Okay, but one way or another, you should end up with 53,240, and since this is area, that would be square miles. Okay, anyone not getting that?
Yeah, I didn't get that.
Okay, so your 250 plus 190
It's
440.
440. Oh, and that, oh.
And then you do, if you took half of 242, you'd have 121.
Yeah, I didn't divide it.
Yeah.
7.
Okay.
So it's supposed to be 30.
Times.
Oh, times. Oh, see, I added.
Yeah, make sure that part of it is still multiplication. So the only time you're adding should be the bases.
Oops, sorry.
Okay. All right. Now, here's where the special right triangle ratios come in. I think I said with the other section, if you're missing a dimension, in the last chapter that we did, we gave you the tools to find the missing dimensions. The key to what we learned in the past chapter was using a triangle. So if you've got a triangle with the right information, then we can apply either the Pythagorean theorem or the ratios if we have a 30-60-90 or a 45-45-90, or we can apply trig in some instances also. So in this case, when you see that you've got a 60, a 30, or a 45, it's kind of a little alert that you're probably going to be using those ratios. Okay. So in this case, we know the bases, but we don't have a height. So we can find the height if you draw your line in there. Okay, and you might still be thinking, well, I don't know anything about that triangle, but you actually do, because if these are parallel, if this is 5, then that piece would also be 5, right? So this piece from here to here is 5, which makes this one 2, the difference, yes? Because they have to add up. Here, let's do this. The whole thing has to add up to 7. So if this is 2 and that is across from our 30-degree angle, that is actually the x part of our ratio, right? Which makes this the x radical 3. And that's the height that we need, right? Okay, so if x is 2, then our height should be 2 radical 3. So now we can put it into the formula, which is 1/2 times the height times the sum of the bases. So that would be 1/2 times 2 radical 3 times 5 plus 7. Okay, and you will leave with these that have the radicals in them. We will simplify keeping the radicals, so you're not going to just pop this into your calculator, all right? So easiest way to do this one is half of 2 is just 1, right? That, in this case, is just going to cancel out. So I would let the half of 2 cancel out. So we've got radical 3 times 12. And when you multiply a whole number and a radical, they go together with the whole number in front, right? So this would just be 12 radical 3 square meters.
And how do you do it the other way if you divide it by 2 afterwards, or can you?
Then you would do 12 times 2 and get 24. keeping the radical, right? So you'd have 24 radical 3 divided by 2, and the 24 and the 2 would simplify to 12. So unless you're looking for a decimal answer, if your directions say round to the nearest tenth, then you can just put it all into your calculator. But if it does not say that, then we would simplify it down, keeping the radical. Okay, we'll probably pick out a couple from the homework, but we're going to go on to the rhombuses and kites. All right, the nice thing about the rhombuses and the kites is they actually use the same formula. So the most important part that you need to know, whether it is a rhombus or a kite, is remember from that chapter, your diagonals are perpendicular, right? That's going to be important information if you're missing something, one of those lengths, okay? This entire, it's hard to show because they cross. Here, we'll do it this way. Okay, that entire length is one of your diagonals. Okay, a diagonal goes from vertex to vertex. And then the other one is your other diagonal. Okay, I hate to draw it in here because I don't want you thinking that just that piece alone can be used in the formula. It's got to be this entire piece and that entire piece. Okay, you will see them like this, but the area is half of D1 times D2. Now, with a rhombus, you want to be careful. You want to look at what information you have, because a rhombus, if you have the diagonals, you can use this formula, but a rhombus is also a parallelogram. So if you've got a side and a perpendicular height, you would use the parallelogram formula. So depending on which they give you, you are going to use one formula or the other. But if you're dealing with the diagonals, you're going with this formula. All right? So the first one we're going to look at is a kite. Okay, sometimes the trouble people have with these is if you're missing a piece, okay, say you're missing that length, we need it. Sometimes people assume that because these are congruent, those are congruent, but you remember, or you should remember back from the quadrilateral unit, that one of these, the long one, is a bisector of the other one. That's why these are congruent. But the short one does not bisect the long one in a kite. So just because you would know that this is 5 does not mean that that is 5. So you want to be careful with that. We are going to do one where you are missing a piece and you're going to have to find it. Okay, but for this one, they're giving you everything that you need. Diagonal 1 is one of them, so we'll just say it's the long one, that's 7. Diagonal 2 is 6. So your formula would be plugging into that. So you'd have 1/2 times 7 times 6. So you could either do half of 42, or if you think differently, some of you might do half of 6 and then multiply it by 7. Okay, but either way, you should be getting 21 square meters. So far, so good? Is everyone done with that? All right. Other one we're going to look at is a rhombus. That is not a good rhombus. Now, it is helpful, sorry, that's a crummy drawing, but it is helpful to know your characteristics of a rhombus if you're missing some information. And in this case, we have, like I said, it could fall under the parallelogram or the rhombus. We have a base, but no perpendicular height, right? So you're not going to use base times height. We have part of a diagonal. Okay, the diagonals of a rhombus do what to each other? They do what?
Intersect, right?
They bisect each other, right? So, for a rhombus, the diagonals bisect each other. They're also perpendicular. So that's good information because we know that those are congruent and we know that these are congruent. Okay, and we have the right angles. Okay, diagonals are not congruent to each other, but at least they bisect each other. Okay, now the problem is, I know this is 12, so I've got that. Okay, but I don't know this. But one of those tools, all right, we're just going to call this X. One of the tools that you have at your disposal now is the Pythagorean theorem. Okay, so we are going to use Pythagorean theorem to find X. And remember, 15 is a hypotenuse, so that should be by itself in the theorem. You don't want to put 12 and 15 together as the sum. So over here, we're going to do 15 squared equals x squared plus 12 squared. So we have 225 equals x squared plus 144. Subtract 144. So we have 81 equals x squared. So x should be 9. Yes? Now, I had already started this when I looked closer, but if you're paying attention, you're going to see in this section or in times where you have to find these missing lengths, 15 and 12 are multiples of our 3, 4, 5. Yes? 3 times as big. So if you notice that, 9 would be 3 times as big as 3, so there'd be your 3, 4, 5. So if you were paying attention, you might have picked up on that, but if not, the theorem works. So our missing side would be 9. Okay, so diagonal 1 would be 24, because it is the whole thing here. Diagonal 2 would be 18. There's the formula you're going to use. So the area would be 1/2 times 18 times 24. So it'd be 216, and I think those were meters. So square meters. All right, so